Hello everyone, I am Dr. Lakhan Chaudhari from PG and Research Department of Chemistry, SPDM College, Shirpur, District Dhule, State Maharashtra. Here I am going to present a micro teaching lecture for the refresher course in chemistry, which was organized by UGC MMTC Kumaon University, Nainital. Today's my topic is mass spectrometry. So let us start with the mass spectrometry. So here it is a powerful analytical technique used to quantify known materials, to identify unknown compounds within a sample, and to elucidate the structure and chemical properties of the different molecules. The separation and analysis of the fragments provides important information about the molecular weight of the sample molecule or organic the substance and the structure of the compound. Today we are going to learn an important rule in case of mass spectrometry, that is the rule of 13. So here the rule of 13 can be used to identify the possible molecular formula of an unknown hydrocarbon. So here the formula is given as CnHm, where C and H are the carbon and hydrogen, and N and M, these values we have to determine, that is the number of carbon atom, and the M value will be the number of hydrogen atom, or with the help of simple example we can done. So here the step one is just we have to determine the N value, and that can be determined here just simply the mass of the this peak, molecular ion peak, and divided by this 13. So only the integer is going to be of 10, and there may be the remainder is there, and the value of M can be determined from the answer, and that will be added with the remainder. So that can be easily understood with the help of simple example. So let us see the example. The formula of hydrocarbon having M plus value, that is the mass value, is 106. So how we can determine the formula for this one? So in the step first, what we have to do, just we have to divide this 106 number by the 13. So when you are going to do that one, you get the answer 8, and 2 will be the remainder for this division. So the 8 will be the number of carbon atom, and then in step second, we have to add this answer 8 with the remainder. So that is the 8 plus 2, and that will be going to give the value of M. And here we can say that the formula for this hydrocarbon will be C8H10. But what about the if there is a presence of heteroatom? So when there is a heteroatom is present, just what we have to do, just subtract the mass of each heteroatom from the molecular weight, and then calculate the formula for this corresponding hydrocarbon. So we have to add the heteroatoms in the formula and replace the carbon and hydrogen. So how we can do that? We can understood again with the simple example. So here a compound with a molecular ion peak at M by Z value is given 102, which are going to show a strong peak at 1739 centimeter inverse in a case of higher spectra, infrared spectra, and we have to determine its molecular formula. So again we are going to use here the rule of 13. So what we have to do, again to find out the value of N, we have to divide this 102 number with the 13. So we are getting this 7 as the answer, and this R will be the remainder. So this 11 is the value, remainder value. So 7 will be the number of carbon atom, and this M, so here that will be from this answer 7 and this remainder. So we are going to add this one, and we are going to get the 18 as a value. So as per the rule, we are going to get this formula C7H18. But as our chemist says that it is not possible, because that will not going to simplify any parent alkane. So this answer can be wrong. So one more information is given, that is a value of iron, and this value 1739. It is going to indicate that it can be ester. So when if you are going to try for the ester, we have the two oxygen atom. So the mass of oxygen is 16. So here, for a single oxygen atom, if you are going to replace, you have to add the oxygen, then we have to replace one carbon and four hydrogen atoms. So it is equivalent weight. This oxygen is 16, the C and H4, it is also having a 16 weight. So for two oxygen atom, we can just replace by the two carbon atom and eight hydrogen atom. If you do that one, then again we are going to get a new formula. The formula becomes C5H10O2. So in this way, we can replace this heteroatom and we can get the formula for the unknown compound. So with this, we are going to stop now. Thank you. Thank you.